Hello, this is Gover Carreno, and Jacob Milstein and I will talk about structure charts.
So yes, in this presentation, we are going to be talking about structured charts, how they're used, what are the benefits, what are the disadvantages of them, and so we'll just get into it here. Structured charts, they represent a hierarchical structure of modules, and then what happens is it breaks down the entire system into the lowest or basic functional modules. And for each one of those modules, it describes the functions and subfunctions of each of those modules and how they relate into or to the entire system in greater detail. See, the structure chart, it partitions the systems into black boxes. You'll see that in later diagrams in the presentation, and we'll go over the different types of modules. But how it works is that the inputs are given into the black boxes or modules, and then appropriate outputs are generated. So module, how it works, whenever you read the diagram, is modules at the top level, they call lower level modules, and then components are read from top to bottom, left to right.
So for the downside, we have that a complete structure chart that shows all the data and control flows for a program can be very difficult to read. The purpose of an structure chart is to show graphically modules, so it wouldn't work well if the system is not modularized. For the upside, an structure chart graphically highlights tidy couple excessively dependent modules that can cause debugging and maintenance problems. Also, a structure chart is an extension of a hierarchy chart, so the core of this tool is consistent with other tools. That means that because this is a type of a hierarchy chart, it can be easily understandable.
So in the next several sections, slides, we will be going over the different symbols used in a structure chart and what they mean and how they relate to other modules in the structure chart.
The first and most important symbol is the module. We have three types of modules. The first is a control module, that is simply a module that have submodules. A submodule is the one that has another module as fodder or is part of another module. And then we have a library module that is a reusable and invocable from any other module. It's kind of a submodule. Here we have our example. Here is our control module. Here we have a submodule, and this one is a library module.
The next symbol in the structure chart is called the conditional call, and it represents a choice that the control module can make in choosing any of the submodules based on some condition. And so whenever you're looking at the structure chart, you'll have your control module, and then the conditional call is represented by this diamond shape.
The loop is a control module that represents a repetitive execution of a module by the submodule. All the submodules covered by the loop repeat the execution of this module. Here is the example. This arrow represents a loop, and all the submodules below repeats the execution of the control module.
The next symbol in a structure chart is the data flow symbol, and what the data flow symbol does is it represents the flow of data between the modules as you would expect, and how it is represented, it is by the circle from where the data is coming and the arrow pointing to where the data is going. And then in this chart you see communication happening from module 1 to module 2, and then module 2 to module 1.
A control flow represents the flow of control between the modules. It is represented by a directed arrow with a fill circle at the end, like in this image. It is important to say here that the control flow is like a flag. It is an answer that the module gives just to say that something is true or false.
The next symbol of a structure chart is physical storage. And physical storage is where all the information is to be stored, or a database. And how this is represented in a structure chart is the square but with the rounded edges.
Here we have an example of the system that we are working on. What the user will do first is to enter his or her user credentials. This information is sent as a parameter to a module that will verify the login information. When this information is verified, that information is sent as a parameter to the database. Then the database will answer if this information is correct or not. Here uh, it's where we can to load the account. So the account information is sent as a parameter to the student account here. Right now we have two options. We can choose to view the degree information or view the available classes. In any of the cases, if we need to see the degree information, we will need to send, as here, like a parameter, the account information, here or here. When we send information to view available classes, we can then sign up for a class. So what we need to do is to send the account information to sign up for a class. So we send this information as a parameter. Then the module that would sign up for a class will answer if the process is successful. So if a class is signing up or not, will be visible again in the View Available Classes module.
So after reviewing all of those symbols in that example, there are two different types of structure charts. We have transform-centered structure charts, and this is represented by several inputs going into one module, that module transforming information with multiple sequences and then outputting it. Or we have the transaction-centered structure, which there are multiple modules that process different transactions and then have several different outputs. And generally, whenever you're making a system chart, this is the preferred method because most of your program you want to be modularized.